Dear student friends, I am Dr. Pradeep Devhate, Associate Professor in Chemistry at Sri RLT College of Science, Akola. This is another video lecture on preparations and reactions of carboxylic acids, that is, benzoic acid and salicylic acid. Let us discuss them one by one. First, benzoic acid, also called as benzene carboxylic acid. It has the molecular formula C6H5COOH, that is COH group linked to the benzene ring. In 1832, Liebig and Oehler established the structure of benzoic acid. It is monocarboxylic aromatic acid. It was first obtained by Scheele from gum benzoin and hence called as benzoic acid. It is found in the form of benzyl esters in resins and Peru balsams. It is also present in urine of horses and oxen in the form of benzoyl glycine, that is hippuric acid. Let's discuss the preparations of benzoic acid. First, by oxidation of toluene. Benzoic acid can be prepared by the oxidation of toluene using alkaline potassium permanganate or by using dilute nitric acid or acidic potassium dichromate. Benzoic acid can be oxidized to toluene either by using alkaline potassium permanganate, dilute nitric acid or acidic potassium dichromate. See the reaction here. CH3 get oxidized to COOH. For this conversion, oxidizing agent used are either alkaline KMnO4, acidic K2Cr2O7 or dilute HNO3. Benzoic toluene gets oxidized to the benzoic acid. This is the first preparation related to the benzoic acid. Benzoic acid can also be prepared by oxidation of benzyl alcohol. When benzyl alcohol is oxidized with alkaline potassium permanganate gives benzaldehyde, which on further oxidation converted to benzoic acid. See the reaction. Initially, CH2OH group get oxidized to the CHO and then to COH. That is conversion of benzyl alcohol to benzaldehyde and then to the benzoic acid. Benzyl alcohol oxidized with alkaline potassium permanganate gives benzaldehyde, which on further oxidation converted to the benzoic acid. Next preparation is by hydrolysis of phenyl cyanide, also called as the phenyl nitride. Again, see the reaction. Phenyl cyanide or that phenyl nitrile on hydrolysis with mineral acids, that is the H2SO4 or the HCl, sulfuric acid or the hydrochloric acid. This phenyl cyanide gives benzoic acid. Here, during this reaction, there is a elimination of ammonia. Phenyl cyanide hydrolyzes with mineral acid like H2SO4 or HCl to give the benzoic acid. CN gets converted into the COOH. Benzoic acid is again obtained by the reaction of benzamide with sodium hydroxide. Reaction of benzamide with sodium hydroxide. Benzamide, when heated with aqueous sodium hydroxide, yields sodium benzoate. It, on acidification, gives benzoic acid. Benzamide initially forms sodium benzoate when it is treated with aqueous sodium hydroxide. Then, on acidification, it gives the benzoic acid. What is the reaction? Benzamide and aqueous NaOH get reacted at about 110 degrees centigrade to produce sodium salt of benzoic acid, that is sodium benzoate, which then hydrolyze using HCl to give the benzoic acid. Now, the reactions of benzoic acid. We discussed the preparations. Now the reactions of benzoic acid. First reaction is with ethanol, that is esterification reaction. Benzoic acid reacts with ethanol in presence of concentrated sulfuric acid to give ethyl benzoate. Benzoic acid undergoes esterification to form the ethyl benzoate. Here, COH group present in benzoic acid get converted to ester by the process of esterification using alcohol and acid. Next reaction of benzoic acid is with phosphorus pentachloride. Reaction of benzoic acid with phosphorus pentachloride. When benzoic acid is treated with phosphorus pentachloride, it gives benzoyl chloride. Benzoic acid plus phosphorus pentachloride in presence of sulfuric acid, it gives benzoyl chloride. Here PCl5 converted to POCl3, that is phosphorus oxychloride. OH get replaced by the Cl. This chlorination of benzoic acid takes place by using the reagent PCl5. Here benzoic acid get converted to the benzoyl chloride. Obviously, here there is elimination of a POCl3 and the HCl. The last one is reaction with ammonia. Reaction with ammonia. On reacting benzoic acid with ammonia, it gives ammonium benzoate, which on further heating gives benzamide. Just see the reaction. Benzoic acid, when treated with ammonia NH3, the salt of benzoic acid, that is ammonium benzoate, is formed. It, on heating, loses the water molecule and forms the benzamide. Next is the preparations and reactions of salicylic acid. Salicylic acid, also we can say it is the ortho-hydroxybenzoic acid. Ortho-hydroxybenzoic acid, it is having the formula C6H4OH COOH. Here benzene ring is having the two substituent at ortho position. One is OH and another one is the COOH. This salicylic acid is naturally occurring carboxylic acid found in certain plants. It is used in making aspirin, drug aspirin, and in the foodstuffs and dyestuff industries. It is also used as a fungicide. As far as the preparations is concerned, salicylic acid is prepared by Rimmer-Tiemann reaction. By the Rimmer-Tiemann reaction. In this reaction, salicylic acid can be prepared by reacting phenol with carbon tetrachloride in aqueous sodium hydroxide solution, followed by acid hydrolysis. This is the Rimmer-Tiemann reaction. Salicylic acid is prepared by reacting phenol with carbon tetrachloride in aqueous sodium hydroxide solution, followed by acid hydrolysis. Observe the reaction. When phenol is treated with CCl4 in aqueous NaOH solution and then hydrolyzed by HCl, gives mixture of orthohydroxy and para-hydroxy benzoic acids. Here orthohydroxy benzoic acid, that is commonly called as the salicylic acid, is the major product as compared to the para-hydroxy benzoic acid. Orthohydroxy benzoic acid, that is salicylic acid, which is the orthoisomer, is more volatile, and so it can be separated by the steam distillation, because here there is a formation of a mixture of products, that is orthohydroxy benzoic acid and the para-hydroxy benzoic acid. Orthohydroxy benzoic acid, that is salicylic acid, is more volatile and it is separated by the steam distillation. Now the reactions of salicylic acid. First, reaction with acetyl chloride. Reaction of salicylic acid with acetyl chloride. When salicylic acid is heated with acetyl chloride in presence of phosphoric acid, that is H3PO4, acetylation of OH group takes place to give acetyl salicylic acid. Here acetyl chloride in presence of phosphoric acid brings about the acetylation of hydroxy group to form acetyl salicylic acid, and this acetylic salicylic acid is commonly called as the aspirin. Aspirin, that is acetyl salicylic acid, acetylation of hydroxyl group present in salicylic acid by using the acetyl chloride in presence of H3PO4. Next is reaction of salicylic acid with methanol, that is again the esterification. When salicylic acid is heated with methanol in presence of concentrated sulfuric acid, esterification of COOH group takes place to give the methyl salicylate. Methyl salicylate is also called as oil of wintergreen. Here, during conversion of salicylic acid to its ester, that is methyl salicylate, COOH group get converted to the COOCH3, and that is by the esterification using methanol and concentrated H2SO4. Last one is the reaction of salicylic acid with phenol. Reaction of salicylic acid with phenol, again the esterification. When salicylic acid is heated with phenol in presence of phosphorus oxychloride POCl3, esterification of COH group takes place and there is a formation of phenyl salicylate. Formation of phenyl salicylate, which is commonly called as salol. Salicylic acid reacts with phenol in presence of phosphorus oxychloride to form phenyl salicylate, that is the ester, which is commonly called as salol. These are the different reactions of salicylic acid. Dear students, this is all about the preparations and reactions of carboxylic acids. Please do concentrate on your studies. Please do watch all the lectures, video lectures posted by me, that is related to the stereochemistry, related to the aldehydes and ketones, and also related to the carboxylic acid. Please watch these videos again and again. Have a good day. Thank you.